Welcome back to our geometry class. Uh, Today we'll learn about another type of transformation called rotation. Remember in the previous lessons we learned about translations, reflections, and now about rotations. We have a few objectives. First, we have to identify the rotation and the rule of rotation and graph rotations on the coordinate plane. Now, what is a rotation? A rotation is a transformation that turns a geometric figure or an object around a fixed point called center of rotation. This point could be any points, but in our lesson, for our purpose, always the center of rotation would be the origin. Yeah? Also, we have a rule of rotation. Yeah? A positive angle of rotation would be counterclockwise, while a negative angle of rotation would be clockwise. Also, don't forget, a rotation preserves shape and size. In other words, doesn't change the shape or size of an object, but changes the position only. Yeah? Good. During rotation, yeah, each point on the object stays the same distance from the center of rotation. Examples of rotations, yeah. So, in this case, we rotated this triangle around the origin, yeah, counterclockwise. Yeah. Here, this rocket was rotated counterclockwise, this around this point called center of rotation. Good. Now, let's talk about a few specific or special angles of rotation. First special angle of rotation is 90 degrees. So rotation of 90 degrees. Rotation of 90 degrees has this rule. Yeah? So let's write here the rule of rotation of 90 degrees. So, in other words, an initial point whose coordinates are x and y after a rotation of 90 degrees will end up in this position whose coordinates are negative x and negative yx. In other words, how you find the coordinates of the new point after a rotation? By switching the coordinates x and y and change the sign of y. Good. Remember, the positive direction of rotation is counterclockwise. Next, another type is of rotation is rotation of 180 degrees. Yeah? In this case, we have this rule. So let's write it on. X, y becomes minus x minus y. This is the rotation of 180. In other words, a point whose coordinates are x and y after a rotation of 180 end up in this location whose coordinates are negative x, negative y. Yeah? So we leave the coordinates in their place, but change their sign. And the last probably the last special angle of rotation is a rotation of 270 degrees. When you have a rotation of 270 degrees, the new coordinates would be y minus x. Yeah? We switch the place of coordinates and change this time only the sign of x coordinate. Of course, another special angle of rotation is a rotation of 360. Is a complete turn, yeah? But the rule of such a rotation would be xy becomes xy. Why? Because after a full turn, yeah, the point end up in the same position. That's why xy turns xy. Good. Let's have an example of each rotation to, figure out each rotation, how does, each rotation looks like. For example, let zoom good. So in this probably I should write here rotation of 270. So, in this example, we have a triangle CDE with vertices CD and E whose coordinates are given. And we have to find the new coordinates after a rotation of 90 degrees. How? First, let's plot the given points. Yeah? C has coordinates 2 and 4. Yeah? So 2 is x coordinates, 4 is y coordinates. So C would be located here. Then D, 6 and 7. 6 is the x coordinate, yeah, is right here, and 7 is on the y coordinates, is right there. Yeah, this is D. And E has coordinates 7 and 3. Yeah, is right here. E. Now we connect them. If we connect them, we get the triangle CDE. Now, we have to find the new coordinates by applying the rule of rotation of 90 degrees. Now, how we find the new coordinates? By switching the place of the given coordinates, right, and changing the sign of y. In other words, if y is positive, becomes negative after a rotation of 90 degrees. If y is negative, becomes positive. So we simply apply this rule. So you're going to have minus 4 and 2. Then negative 7 and 6. And negative 3 and 7. Huh? Now we plot these points. So you're going to have minus 4 and 2 is C prime, negative 7 and 6, this is E prime, and E prime is negative 3 and 7. If you connect them, you get the new triangle after a rotation of 90 degrees. As I said before, the rotation of this triangle is around a fixed point called the center of rotation. And the center of rotation in our lesson would be the origin, yeah? Good. Now, if you connect the origin with C and the origin with C prime, yeah, you'll get the angle of rotation, which supposed to be 90, yeah? But remember, the positive direction of rotation is counterclockwise. So, you have this angle, right? Which is 90 degrees, is a right angle. Again, rotation preserves the shape and the size, yeah? The triangle is the same after a rotation. Good. Next, let's have an example of rotation of 180. So this time we have a quadrilateral MNOP with vertices negative 6, 8, negative 1, 4, negative 2, 1, negative 7, 2. And we have to rotate 180. So in this case, we apply this rule. Yeah? So as we can see, X and Y don't change their place, but change their sign. If they are positive, turns negative. If they are negative, turns positive. Simple, yeah? Now, first, let's plot the points, the given points, these points. So, negative 6 and 8. This is N. Then, negative 1 and 4. This is N. Negative 2 and 1. This is O. And negative 7 and 2. This is P. Okay? We connect them. And we get this shape. This shape is called pre-image. Why is pre-image? Because it is the shape or the object before transformation. In our case, rotation. Now, we have to find the new coordinates and plot them. So, we apply this rule. So, as we can see here for M, X is negative. Because it's negative, according to this rule, turns positive. So, it's 6. And because Y is positive, turns negative. And we do the same with all the other coordinates. So, you're going to have 1 and negative 4. 2 and negative 1. 7 and negative 2. And now we start plotting these points. So, 6 and negative 8. 6 and negative 8. 2, 4, 6, 8. Somewhere here. And prime. 1 and negative 4. 1 and negative 4. 1, 2, 3. 2 and negative 1. 2 and negative 1. All right. And 7 and negative 2. 7 and negative 2. P prime. And then you simply connect. Again, the center of rotation is the origin. If you connect O and the origin and O prime and the origin, okay, you'll get the angle of rotation. Yeah? So the angle of rotation is 180. Yeah? Is 180. Good. Now, the last example of rotation rotation of 270 degrees. Probably, yeah. So we have the triangle PQR with vertices P, Q, and R whose coordinates are given here. So we need to find the new triangle after a rotation of 270 degrees. So we apply this rule. In this case, we switch the place of the coordinates and change the sign of x only. So if x, the initial x is negative, becomes positive. If it's positive, becomes negative. Simple. Yeah? So let's plot the given points first. 1 and 3. 1 and 3. This is P. 4 and 8. 4 and 8 is Q. R is 8 and 1. 8 and 1. This is R. Okay? So you connect them and you get the pre-image. Now let's find the new coordinates. Remember how you get the new coordinates? By switching the place of the coordinates and change the sign of x. So you're going to have 3 and negative 1. Then 8 and negative 4. And then 1 and negative 8. So let's plot. So you're going to have 3 and negative 1. This is P prime. 8 and negative 4. Q prime. And 1 and negative 8. R prime. And then you connect. Yeah? So, how we emphasize the angle of rotation? By, let's say, we connect, for example, points P and P prime with the origin. Yeah? So, the angle of rotation of 270 would be this angle. Yeah? So, for now, it's all we have for this lesson. We'll see soon with a new lesson. Thank you for watching my video.